Okay. Friday. We are week number 1, day 2. Introduction to computers. Excuse me. Introduction to networks. We reviewed some course details, make sure that was cleared, and then talked a little bit about exploring networks. We did not practice packet tracer, and we took the pretest. Alright, let's move on to the next page. We talked a little bit about media and wire. Protocol, rules of communication. We talked about client-server. We'll talk some more about that in the diagrams, and we also talked about peer-to-peer networks. We talk more about this later on. We tried to we distinguished some steps here to understand the difference between IP addressing and physical addressing. So we could think of the whole thing here as a frame, and this here as a packet. And in there we have these here in the front. We have the MAC address, the physical address, destination and source. And inside there we have IP addressing, destination and source. We have port, and then stored somewhere in there is the data. You know, this is what's being sent, and the rest of that is packaging to get it where it's supposed to go. Alright. Students asked about a hub. Well, a hub is different than a switch because it would just broadcast the signal out, and all the other devices would look at it, and the device that it's meant to go to is where it would go in. Broadcast the physical and IP address. Then later on in the history of networks, we get a bridge in which that would be able to separate. So signals within this network could stay here, and if the address was on the other side, so we have a PC, it's going to communicate to a PC over here. Then the bridge would move it across. Switches nowadays look at all the ports, and they work much more efficiently because they identify the MAC address on all the ports, and so they will send it out only the port needs to send it out, unless there's some reason we need to do a broadcast, which we learn about, which we later on. Broadcast, we send it everywhere. And we do broadcast in networks. Now let's take a look at this up here. I drew a line here trying to indicate where the edge of the network is. And then we have devices. We have a PC maybe, or a laptop, or a phone. And devices that will eventually communicate in to a networking device, like an access point or to a switch. So we think about the edge of where those go in. Then we have network devices. We have multi-layered switches, we have layered 2 switches, we have firewalls, we have routers out here in the internet exchanging traffic. Now in our example in here, we showed the difference. We had NIACs, network, and then we have this. I kind of separated it off here. Somewhere's in there we have the academic IT, and then we have, you know, the main campus here at Nyack. That's not proportionate. We talk about communicating out then, out through the internet, going to Nyack connecting to Charles City, or somebody at Nyack connecting to some web server. We use example of a web server where I have information stored out there on the internet, via the internet to some services that I paid for. Then in the next diagram, we talked a little bit about this situation. We have the OSI model. This first introduction to it. By the end of the term, you will be very familiar with it, especially certain parts. There's entire chapters about this. So we have applications with PuTTY, browsers. The browsers produce URLs, secured and not secured communications. The application layer connects into whatever software we're using. We present the data, we create a session, then we figure out how we're going to transport it. This is really all you need to know. Then we put an IP address on it. Okay, that'll move it through the broader networks. And then more specifically around our LAN, we add a MAC address, and then we figure out how to put it on the physical medium. Wired, wireless, or fiber. Physical layer. And then the information moves through our network. So if I was going to give an example of this PC, or let's do this. Let's say I'm at home, I've got a PC, and I'm going to log into a server here. One of the servers here at Nyack that we use to access equipment. Work server 1 or 2. I could type in the IP address. It then would get information from my PC to the router, okay, using a physical MAC address. And once it leaves there, it doesn't need the MAC address. It'll convert it to a public IP, put it in the internet. The internet will move it through the routers and end up at the ICN, which will bring it in and send it over to the server. And then the server would return the traffic. And we talked a little bit about that process, which I'll talk about a little more specifically in the last slide. Okay? So let's take the next look. We're actually going to, I mentioned it, we're going to learn about these specific layers in different chapters. This will be more lump sum together, but we'll learn about all those in this particular course. So, let's look at this more specifically. So if I was going to go out, we have Canvas where we have the Cisco, we have Canvas where we have the college information connected to the internet. So I would use some URL, just an example. That URL would use DNS to get an IP, and that IP address, the destination IP, I'm leaving the main campus here or somewhere here in campus, would stay the same. So it would use physical addresses to get me to here. Then it would send it out to the ICN. My internal IP would be converted to a public one. The internet would push it through to wherever I'm going. Okay. Then they would take that information, process it, and then they'd use the source IP as a destination IP, send it back in the internet using that public address. I would get it to the ICN, it would get it internally, convert it back to a private address, and send it to my computer. Let's take a look at that one more time before we So if we're using a browser, the information would move down through our hierarchy here, and when it gets to this point, our data, which is just a URL, would get a port number, and it would either get port 80 or 443, depending on if it's HTTP or HTTPS. Then I'll get an IP address, source and destination, and it puts a MAC address on it. The MAC address would get it up through until this routing device. And then that'll look and see if it should be routed this way or this way, looking at the IP. Once it routes it this way, the firewall puts a public address on it and then looks to see if it actually sends it to this device. It sees if it should go to the main campus. If not, it sends it out on the internet. The internet uses that public address to take it to its location. Let's just say here. And the process is actually reversed. It comes back in, and eventually it ends up to the server. And then the server reverses it and then does the exact same process to send it back. So at this point in time, we need to be able to distinguish end user devices, where the edge is, however you might define the edge, between those devices and where they connect into a network. Once in the network, we have all these devices in the network, like access points, switches, multi-layered switches, which means they function at multiple layers over here, and routers, like routers out on the internet, communicating to each other. Alright, that's it for today.